Alright, in this last video in section 11.3, we're going to look at question number 7. This problem says that the amount of light energy reaching a surface per unit time is called the intensity of the light. The figure shows light striking a surface at 3 different distances from the source. So we have some light source here, maybe a candle, and light is emanating out. And in part A it says how many square feet are lighted by the candle at 1 foot. At 2 feet, how about at 3 feet? Okay, so when our distance from the source is 1 foot, right, I see just a 1 foot by 1 foot square area that's being lit up, right? So here, when the distance is 1, the square feet lit would just be 1 square foot, okay? Now, when I move out to a distance of 2 feet, right now what I'm doing is I'm going to take this same amount of light, but now I'm going to spread it out over a 2 foot by 2 foot grid, right? So now I'm going to be lighting 4 square feet, 2 squared, right? And then likewise, if I move 3 feet from the source, now that same amount of light is illuminating a 3 foot by 3 foot grid, or in other words, right, an area of 9 square feet. Okay, great. So now moving on to part B, it says what happens to the light intensity as the distance from the source increases. Okay, so the thing you got to keep in mind here when you're looking at this figure is that at each distance, right, the amount of light is the same. Okay, so at 1 foot we have this amount of light, right? You can think about it like some amount of paint. Now if I move 2 feet out, right, this is capturing the same amount of light, but it's just spreading it out over a larger area, right? And then likewise when we're 3 feet out. So in turn, right, as we move further out, the intensity of the light should be decreasing. So here I'm going to say as the distance from the source, that's D, increases, the light intensity, which I'll go ahead and call I, is going to be going down. Okay? And now part C is going to have us state this relationship in a little more detail. So state the relationship between the light intensity I and the distance D from the source. Okay, so for that, I'm going to go ahead and make a little table here. I'll put D, the distance from the source, in the first column. This is like X. And then I, the intensity of the light. That's like our Y. And let's say when I'm 1 foot away from the source, okay, I'm going to call the intensity of the light here, I'm going to call it some number K. I don't know what that number is. And by the way, there are units used to measure light intensity. The most commonly used unit is what's called a candela. Now we don't actually have to need that, or we're not going to use it, but there's some amount of light there when we are 1 foot away from the source. Again, you could think about this as like some amount of paint. Like this is a gallon of paint when we're 1 foot away. Now when we go to 2 feet, again, the key here is that I'm taking that same amount of light and I'm spreading it now over a 2 foot by 2 foot grid. So I'm going to take the original amount of light, that's K, and I'm going to divide it by 4. Okay? And then when I go 3 feet out, again, I'm going to take that original amount of light and now I'm going to divide it, right, up into 9 equal parts. Okay, so here again we see as the distance is increasing, the intensity is decreasing. And so what I can say is that for writing an equation, right, the intensity is what? I'm doing K divided by, and notice here, right, like when say the distance is 3, right, the denominator for the intensity here is 9, and that's just 3 squared. Right? When the distance is 2, the denominator for the intensity is 4, and that's just 2 squared. And when the distance is 1, right, you can think of just K on its own as really K divided by 1 squared. So more generally, right, we're taking the original amount of light, right, K, and we're dividing it by the square distance. Okay? Now this has a special name, by the way. This is what's known as an inverse square law. And there's all kinds of things out there in the physical world that obey physical inverse square laws. Things like gravitational fields, electromagnetism, in this case, light intensity. But yeah, they're everywhere. Okay, well that's a good place to stop. All right.